Okay, so here we are, section 1.5, which is now we're shifting to multiplying. This one actually is multiplying, isn't it? Negative 22, negative 10. See how the parentheses are right up against each other with nothing in the middle? So that is multiplying now. So you can use a calculator, of course. You guys know the rule, though. What's the rule with the two negative numbers multiplying? Going to be positive, yeah. So two negatives multiply, or they also divide. Same rule for dividing, huh? Which is our very next section in 15 minutes here. Two negatives multiply. That says negative. Two negatives multiply or divide to be positive. So these two negatives are going to make a positive. And then what happens when you multiply anything by 10? Just puts a 0 on the back, doesn't it? So that'd be 220. You use a calculator if you're not sure. But it's going to be positive, or you don't even need the plus sign, just regular 220 on that. Two negatives make positive. All right. Okay. So now we're multiplying 2. That dot means times. Multiplying. The bottoms are already the same, but even if they weren't, remember, we don't care, huh? For multiplying, you don't have to make the bottoms the same. They coincidentally are, but it's not required. Multiplying is easier. What do? You just go straight and straight. Top times top, bottom times bottom. 9 times 8, 72. 5 times 5, 25.
Why is that in parentheses?
It's just meaning, it's not needed. Those parentheses are kind of overkill. They're just like extra, emphasizing its times.
Oh, okay,
Yeah.
okay.
Even without the parentheses, it would still be times because you got the dot there.
Yes.
It's kind of like double the same.
Okay.
Yeah. So, just multiply straight. And then you reduce that fraction if you could, but you can't. There's nothing that divides into 72 and 25. So we're just done right there. It's okay to leave the top bigger. That's totally fine. So that's the answer. Just straight. Not required here to make it into a mixed number. They don't require making mixed. They do require, if anything, can divide out of both of those. But nothing goes into 72 and 25, so we just leave it. Yeah, so all they require is common dividing, but not changing to mixed. Yeah. So this one, we don't need a common denominator, so what do? We just go straight. Well, there's actually two ways. Let me show you two ways. First off, you could just go straight. That's totally fine and good. 6 times 3 is 18. 2 times 5 is 10. But that one will need to be reduced, not because the top's bigger. We're fine with that. But because 2 goes into both of them. So when something goes into both of them, yes, you do have to do that. So I'm going to say, okay. So divide by 2, and we'll get, 9/5, and that's fine. Again, we don't have to make it a mix. 9/5 is fine. What's the other way we could have done that problem? That way was fine, but what's the other way we could have saved a step?
Cross multiplication.
Cross canceling. Cross multiplication is when you have an equals in the middle. We'll get to that a little bit later. Cross canceling, you got the right idea. Cross canceling is what we could have done. So that's another way. Basically, I could have gone 2 goes into 6 3 times. It's just a quicker way. What it is, it's doing your reduction early instead of late. That's all it is. It's going to be the same answer in the end. So 2 divides into 6 3 times, and then 3 times 3 would be 9, and all you got left on the bottom is 5. There it is. You got 9/5 without having to do the later reduction. Because you're doing the reduction in the beginning is all it is. Cross-canceling is just simplifying early. That's all it is. So it's your option. You can cross-cancel, or you can simplify at the end. Like that. Cross-cancel means diagonal. Right? Diagonal cancel. Like that. Remember that? Either way is right. Okay, so we have -4 times -3 times -5 times -5. Okay, so how do we multiply together a whole bunch of things and determine the sign? Is the sign on this one going to be positive or negative in the end? Let's figure that out first.
Positive.
Good, because every 2 minuses make plus, don't they? So these 2 minuses make plus, and these 2 minuses make plus. So if you have an even number of negative signs, like 4 or 2 or 4 or 6 or 8, it's going to be positive in the end, isn't it? If you have an odd number of negative, like 1 negative or 3 or 5, it's going to be negative in the end. Does that make sense where I'm coming up with that? Because every 2, an even amount, makes positive. So if you like have a third one, then it'll be back to negative, won't it? So if you have an odd, so we just count the minuses. I just go 1, 2, 3, 4. That's positive, positive. It's going to be positive. So I know the answer is positive something, and then I would just do the rest on my calculator. I would just say, all right, it's positive something, and then I just go 4 times 3 is 12. Calculator 60, is it 300?
Yep.
Positive or regular 300. So I think it's easiest to figure the sign by hand, like that. Good on that? You stop me if you have questions. I know I'm flying. It's on YouTube if you... Okay, big ugly mess. I'll let you write that whole thing down. Let's figure out the sign first off, and then we'll do all the mess of the numbers. Is this one going to be in the end?
Negative.
Yeah, it's going to be negative, isn't it? Because we have 3 minus signs. All right, everybody good with that? Because like 2 of the minus signs make plus. But then, so 3 negatives, it's going to be negative. So it's going to be negative something in the end, isn't it? So now we can just forget about the signs and just focus on the numbers. By the way, if you have the Casio Natural Display, and some of the other calculators as well, you can just enter these as fractions and hit the button, and it'll take care of it. Do you know what I mean? It depends on the calculator, but maybe it'd be worth it. Maybe it'd be worth it for me to show that for a second. I'll leave it there. Okay. So -1 to the 15th power. What does that mean? What does that little 15 power thing mean up there? Yeah, whole bunch of them, huh? It means -1 times -1, times 15 of them. That's what that means, right? So what's that going to be in the end? -1, huh? It's going to be negative because there's an odd amount of negative signs. 15 is odd. And so there's going to be 1 extra. There's going to be 7 pairs that make plus and 1 extra that turns the final thing to negative, isn't there? That makes sense? Remember we said back here a minute ago, we said if you have an even amount, it's positive. If you have an odd amount, it's negative. So that's why, because when they're in even pairs, there's no extra odd. But if they're odd, there's 1 left over. So it's going to be -1. So the answer to that's just -1 when all is said and done. With this long word problem. Suppose there's a 3-degree drop. Can you read that? I couldn't make it bigger. It went off the screen. It's a 3-degree drop in temperature for every 1,000 feet that an airplane climbs into the sky. You know, as you go higher, the temperatures get colder. That's why they have, what's it called? The atmosphere control in planes. But when planes were when they first came out with planes, they used to just wear really warm clothing. I don't know if you know that when they went high. I just finished listening to Winston Churchill's biography, and that was kind of around the time some of the first times they were using planes. And so he would get on a plane sometimes, need to fly to some meeting in Russia or something to meet Mr. What's his name, Stalin. And so they would just bundle up with all these huge jackets, and they'd go up, and the plane would be like freezing temperatures in the cabin of the plane while they flew over somewhere. So anyway, there's as you go higher, the temperatures drop. 3-degree drop in temperature for every 1,000 feet the airplane climbs. If the temperature on the ground at sea level is 48, what would be the temperature when the plane reaches 28,000 feet? Everybody guys are here for that. All right, just a second.
Whenever you're ready.
Sounds good. All right, so 28,000 feet. So how's this work? So every 1,000 feet, it's a 3-degree drop in temperature. So how many 1,000 feet did they climb? 28,000 feet. So every 1,000, the temp is going to drop 3 degrees. So the temp will drop 28 times 3, won't it? 3 degrees, 28 times. Every 1,000 feet. The first 1,000, 3-degree drop. Next 1,000, next 1,000, next 1,000, right? 28 times that temperature will drop 3 degrees. So what's that? 60, 24, 84. 84-degree drop. And what was the original temperature when they left? Oh, that's going to be crazy cold. It was 48 at sea level. They shouldn't have went up on a day when it was 48 at sea level. So 48 drop 84, something big negative. What is that? Negative 36? Is that what it is? I think. Am I doing that right? You guys have a calculator? It's going to be negative 36 degrees. That's why they have cabin sealing stuff, and they seal the atmosphere in airplanes and do all that now.
Air pressurized.
There it is. Yeah, that's right. Your husband's a pilot or something, huh? You know the words. That's right.
I do.
Air pressurized. Otherwise, they would be freezing cold like they were when they first flew. Good on that? That makes sense? All right, so we're done with this section.